video is going to show how to do problem 4.1 in Siegel. So, and one more thing, it's going to do it in both SPSS and R. So I've typed in the data set into SPSS. It took me about 30 seconds to type those 15 numbers. So problem 1 asks us questions like what is the mean, the median, various percentiles, generate a histogram, generate a box plot. So all of these can be accomplished in SPSS under Explore. So we're simply going to go up to Analyze, Descriptives, and then Explore. You're going to find that this is one of the most useful functions in SPSS for getting to know a data set. We'll copy the variable into the dependent list. Then let's go into a few of the menus. So if we go into statistics, let's get percentiles. That's going to allow us to answer part I. And then if we go into plots, you can see that you can request a histogram. So let's get a histogram, forget the stem and leaf. And that's about it. If you go into options, let's see, we don't need to do anything under options. Just go ahead and hit OK at this point. And SPSS is going to take a second. And so now my claim is that we can answer just about all the questions from this output. So part A is what is the mean? Well, mean's 15.6. What's the median? The median's 14. Draw a histogram. Well, the histogram is down here. It's kind of hard to draw any firm conclusions from a histogram with only 15 observations. There's just way too much sampling variation. So if we draw on a different sample from the same population, the histogram might change a bit. This appears that we have two modes, but it's kind of hard to say at this point. Find the mode. Yeah, I told you to omit this. The mode seems to be in this region, but you're going to look in the histogram for large height spikes. So if we think it's bimodal, one mode would be in this neighborhood in the mid-20s. Another mode would be down here in the around 5 or so. So if it's truly bimodal. Next part is find the quartiles. Well, the quartiles are given to you in this box. Part F, find the extremes, i.e. the largest and smallest. Well, the largest and smallest are up in this this box where I'm pointing my cursor right now. Draw a box plot. Well, you see we have our box plot. The box plot doesn't show the bimodalness. I told you to omit the cumulative distribution function. Find the 90th percentile. The 90th percentile is about 31.6. Find the percentile of the value 29. This is the only one that's not easy to do on this particular output. Let's go back to Analyze Descriptives, and let's get a frequency distribution of this variable. Go hit OK. And so what you'll see is that the value 28 is about 86–87% of the way into the data, while as the value 30 is 93% of the way into the data. Now part J says, what is the percentile ranking of 29? Well, 29 is somewhere in between 28 and 30. So somewhere in the range of the 88th percentile is about right. I'll give you credit for any number between 86.7 and 93.3. So that's how we do it in R. If we want to do this that's how we do it in SPSS. As for R, I typed it in. Here's how I typed it in. I typed it in before starting the video. And if we do a summary of X, you'll get the 5-number summary. So here's the smallest and the largest. Here's the mean, the median, and the quartile. So that answers quite a few parts of the exercise. To get a histogram, I just type hist_x. And let's see, I've hidden the window. Let's go find it again. And sure enough, you see the bimodalness. The only thing I really haven't answered at this point, we need a box plot. Okay, so box plot X shows us the box plot. again, we don't see the bimodalness. I think that's the point of this exercise. What I don't have is the 90th percentile. So to find that, I'm going to type in quantile and then x, and I have to tell it which quantile I want. So I want the 0.9 or 90th percentile. And so they give you a slightly different one than SPSS. In fact, you'll note the quartiles are a little bit different as well. So I warned you in class that different software computes these quartiles differently. You'll see that R gives the first quartile of 6, which is what you get with the 2 keys hinges approach. The answer key in the course packet says either of those is right. Likewise with the third quartile, 24.5, a little bit different than SPSS. This is due to the way you interpolate between values. At this point, I'd like to well, we didn't get the frequency distribution. So if I do a table of x, we get this. Then if I do a cum sum of table of x, and let's divide this by 15, now you're going to get the cumulative distribution. So you'll see that you're 87% of the way in at 28. You're 93% of the way in with 30, so the value 29 is going to be between those. One other thing I could do, there's something called a non-parametric density estimate, which is an alternative to a histogram. We can get that with the density function. So you say plot density x, and then we want to tell the plot function to connect the dots. So if you say type equals L, that'll get it to connect the dots. So let's go look at that graph. And so what you'll see is that this density estimate shows some bimodalness as well. Another command that I really like in R is rug. This adds a little line, so these look like shags of a carpet. And you can see the actual data. So you've got one value down in that trough. Other than that, you've got a clump of values here and a clump of values here, supporting this notion that we might have a bimodal distribution. All right, that's it for problem 4.1.